In this video, we're going to do a quick example related to the empirical rule and z-scores. Recall that the empirical rule tells us that if we have a set of data that's normally distributed, then the empirical rule gives us these percentages as shown here in this picture. Where we're going to find that about 68% of the data falls within one standard deviation of the mean, about 95% of the data falls within two standard deviations, and more than 99% of the data falls within three standard deviations. If data falls beyond three standard deviations, then we consider that data to be unusually high or unusually low. Recall also that to calculate the z-score of a data value, we take the data value minus the mean, and then we divide that by the standard deviation. A z-score will tell us how many standard deviations that a data value is from the mean. So we're going to do an example. It says, suppose that the weights of 5-foot 6-inch women in a certain town are normally distributed with a mean weight of 140 pounds and a standard deviation of 5 pounds. So we're saying if you did create a distribution for this set of weights, we would find that 140 pounds is the mean value right in the middle, and one standard deviation would be 145 above. Two standard deviations above would be 150 pounds right here. This is pounds. This is 150 pounds. And three standard deviations above would be 155 pounds. Similarly, on my normal curve, I could label going downward. So 140 pounds is right in the middle of the mean, and 135 pounds is one standard deviation below. 130 pounds is two standard deviations below, and 125 pounds is three standard deviations below. So it says to find the z-score for a woman who is 147 pounds. So first of all, notice on my diagram here, 147 pounds would lie here between 145 and 150 pounds. So I expect the z-score to be between 1 and 2 standard deviations. I expect the z-score to be somewhere around 1.5. It's between 1 and 2 standard deviations above the mean. So let's find it. The z-score for 147 pounds. We take the data value, 147, minus the mean, which is 140, and we divide it by the standard deviation, which in this case was 5. I get 7 divided by 5, which is 1.4. So it's saying a woman with a weight of 147 pounds in this town would be 1.4 standard deviations above the mean. So that would be a woman who's about right here on the chart. Similarly, let's find a z-score for a woman who's 127 pounds in that town, a 5-foot 6-inch woman who's 127 pounds in that town. So we take the data value 127 and we subtract the mean 140, and then we divide by the standard deviation, which is 5, and we get a value of negative 2.6. So that woman would have a weight that had her fall about here on the chart. She's between negative 2 standard deviations and negative 3 standard deviations. So she's way down here. Notice she's between 125 pounds and 130 pounds. That's the 127-pound woman. She is 2.6 standard deviations below the mean. That's why she has a z-score that's negative. She falls below the mean. She's less weight than average. And now let's try it backwards. It says find the weight of a woman who has a z-score of 1.6. So in this case, we're going to solve for the data value when we have a known z-score. So the z-score formula says that our z-score is 1.6, and that equals the data value, I'm going to call it x, minus the mean, which is 140, divided by the standard deviation, which is 5. To solve for x, I'm first going to multiply both sides by 5, like so. That cancels the 5 on the right side, excuse me. On the left side, I have 5 times 1.6, which is 8. So now 8 is on the left side and x minus 140 is on the right. I add 140 on both sides to isolate the variable. So on the right side I have x, and on the left side I have 148. So my data value would have to be 148 in order to get a z-score of 1.6. She would have to be 148 pounds to have a z-score of 1.6. And let's just check that on the chart. The z-score of 1.6 would fall between 1 and 2, so that would be right in this area. And she would have a weight of 148, so yeah, that makes sense. It would be between 145 pounds and 150 pounds. Find the weight of a woman with a z-score of negative 0.9. So our z-score is negative 0.9, and the z-score formula says z-score equals the data value, I'll call x, minus the mean, which was 140, divided by the standard deviation, which was 5. To solve for x, I multiply both sides by 5 first, and I take 5 times negative 0.9. I get negative 4.5. And on the right side, I just have x minus 140. To solve for x, I add 140 on both sides. And so it cancels on the right, leaving just x. And on the left, we have 135.5. The woman would weigh 135 and a half pounds. And again, let's check it. 135 and a half pounds would be down here between 135 and 140 pounds, just a little bit to the right of a z-score of negative 1. And that makes sense then, z-score of negative 0.9. That's a little to the right of a z-score of negative 1. Next, it asks how much would a 5-foot 6-inch woman have to weigh to be considered unusually heavy in this town? So this is just a reminder of what we would consider unusual on a normal curve using this empirical rule. So to answer this question, we want to remember that unusual data values are data values that are more than 2 standard deviations away from the mean. So right in the middle is the mean that has a z-score of 0. It's 0 standard deviations away from the mean. Then you can go up 1 standard deviation, up a second standard deviation, we'd be right here. So 2 standard deviations above the mean is 150 pounds. Anything higher than that would be considered unusually high. Similarly, 0 is the mean in the middle. You can go down 1 standard deviation to 135. You can go down a second standard deviation to 130. So 2 standard deviations below the mean is 130 pounds. Anything below that would be considered unusually low for this normal curve. So how much would a 5-foot 6-inch woman have to weigh to be considered unusually heavy? She'd have to be more than 2 standard deviations above the mean. That would be more than 150 pounds. How much would a 5-foot 6-inch woman have to weigh to be considered unusually light? That would mean that was a woman who was more than 2 standard deviations below the mean, so that would be less than 130 pounds.